All right, so in this example, this is going to have something happen a little different in it than the previous example. First, let's start by looking at degrees of the numerator and the denominator. That'll help us with our horizontal asymptotes. So degree of the numerator is 2, and of the denominator is 1. Remember, just look at the highest power in each of the numerators and denominators to help you determine that, right? So we want to make a comparison between the two degrees. Here, the degree of the numerator is larger than that of the denominator. So we go back, we look at our horizontal asymptote rules. We are in this situation. That means there is no horizontal asymptote. So I'm just going to write none here. Okay, now let's try to factor and see if anything simplifies to help us with the vertical asymptotes and the holes. Top factors to x plus 4 times x plus 5. Bottom, you can pull a 4 out. And from that factored denominator, I can tell you we would be undefined at -5, right? But then we could reduce away the x plus 5s and simplify this to x plus 4 over 4. Is that simplified version, x plus 4 over 4, is that undefined anywhere? No, there's no variable in the denominator anymore, right? So I'd say here, no undefined values, which means there's no vertical asymptote either. If the simplified version has no undefined values, you do not have a vertical asymptote. Now you will have a hole at the original undefined value of -5. Okay, now remember, a hole is also referred to as a point of discontinuity. It's supposed to be an ordered pair with an x and a y. So to get the y coordinate, I will plug -5 into the simplified version of this function. So -5 plus 4 over 4. That's going to give me -1/4. So the hole is at the point -5, -1/4. Okay, let's go ahead and estimate the location of that and just plot it as an open point. So that would be right about there. All right, now we get our intercepts the same way we would with any other function, right? So y-intercept, I would plug 0 in for x. I'd be trying to find f of 0. That would simplify to 1. So on the y-axis, plot a point at 1. X-intercept, you're going to plug 0 in for y. Solve that for x. Multiply by 4 to clear the fraction. 4 times 0 is 0, equaling x plus 4. That means x is -4. Okay, now, if you notice, the 2 points that I plotted and then also the hole, the 3 of those together look like they're kind of lining up in a line, right? And that's exactly what we have here. This really, the simplified version of this is linear. X plus 4 over 4 is the same as 1/4 x plus 1. That's in slope-intercept form, isn't it? So it's got a y-intercept of 1, and it has a slope of 1/4. That matches the points we already have plotted. So knowing that, I can get some more points here. From the y-intercept, I could go up 1, right 4 a couple of times. And from the x-intercept, I could go down 1, left 4. So really what we have here for the final graph is simply a line with a hole in it. Any questions? All right, now the final example, this one ends up working out a lot like example 1. Okay, let's start with degrees again. Degree of the numerator is 1. Degree of the denominator is also 1. Those are equivalent. Go back and look at your asymptote rules. We are now in the bottom situation right here, where the degrees are equal. That tells me I'm supposed to look at the coefficients on the leading terms. Use those to get my horizontal asymptote. So I should be looking right here. I can say the horizontal asymptote is y equals -3/2. Go ahead and draw that in. Okay, then let's factor numerator, pull a -3 out. Denominator, pull a 2 out. Looking at the denominator, I could say we're undefined at -3 for x. Now, after factoring, nothing reduces, right? I cannot simplify that any further. So that means the simplified version still is undefined at that -3. That means we have an asymptote there, a vertical one. Draw that in. That also means we have no hole. There was never a time where we were initially undefined and then after we simplified, we became defined at that value. So no hole this time. All right, y-intercept, f of 0. Now you could plug the 0 into the original function or the factored form. It shouldn't matter. I'm going to use the factored form. So that's going to give me -15 over 6, which reduces down to -5 over 2, or -2.5. So plot a point on the y-axis there. And to get your x-intercept, 0 equals -3 times x plus 5 over 2 times x plus 3. Could clear the fraction, multiply both sides by the denominator. Well, 0 times anything is 0. Now here I could solve a couple ways. I could distribute the -3, or why not just divide it out right away? Zero equals x plus 5. X is -5 then. Plot a point on the x-axis at -5. All right, so now we need a couple more points for each half of the curve. So we'll do a table, just like we did back in example 1. And I want to pick values for x to plug in that are on either side of the vertical asymptote, okay? So I think -6 would be good. -5, I already know that's going to produce 0. That's the x-intercept. I could do -4. I know -3 is where I'm undefined. That's the vertical asymptote. And then let's do -2 and -1. That should be plenty. Okay, now I personally like plugging these into the factored form. You could use the original if you want, but I think the factored form is a little quicker. So if I plug -6 in, -6 plus 5 is -1. -1 times -3 would be 3 in the numerator. And then down below, -6 plus 3 is -3 times 2, that's -6. So that's going to ultimately give me -1/2. If I plug -4 in, I'll get -3 in the numerator over -2. So that's 3/2. And I can certainly see from those 3 points and the asymptotes how this side of the curve's behaving. Remember, when you draw the curve, don't let it touch your asymptotes or cross through them, right? That's the whole idea of an asymptote. The curve's getting infinitely close to those two lines, but it's never actually going to touch them. All right, now plug your -2 in. So -2 plus 5 is 3. 3 times -3 is -9. On the bottom, you get a 2. So -9/2 or -4.5. Okay, and then if I plug -1 in, I'm going to get, let's see, a -12 over a 4. So that's nice, -3, exactly. And there's the second half of the curve.